Hi, I'm here with Mark Saroufim from GPU Mode. Mark, welcome.
Oh, thank you. Thanks, Anush. Thanks for having me.
Thanks for taking the time. Can you tell us a little bit about GPU Mode?
Sure, yeah. So GPU Mode was initially called CUDA Mode. It was a community for myself and my good friend Andres Scope to learn CUDA. But since then, it's grown into like a community where people meet up on a weekly basis for like very deep technical lectures. People build projects in the open. Some of those projects went on to be very successful in their own rights. Famous ones like LM.C by Carpathy, Torch.io, which I worked on myself, Liger, now poached by XAI. So I think like people are doing really good stuff in the community, and it's just been fantastic to see.
Awesome. That's very interesting that it went from GPU CUDA mode to GPU mode.
Yes.
And I think that speaks to the general desire for a hardware neutral kind of ecosystem. And so it's great that you're taking active participation in getting us there. What are the challenges that you see in just general AI adoption? Let's start with that.
Yeah, so like I would say like so the sort of main one is like I was like checking out this like very interesting thread from way back in 2015. It was a thread on TensorFlow where people were quite upset that like why are you not like properly supporting like OpenCL, and like, this was like an issue with like hundreds of comments and hundreds of threads. Like people wanted an open ecosystem, and when I read it, I'm like, like it seems like we kind of gave up on that dream because like none of these hardware neutral languages really figured out how to get like state-of-the-art perf.
Yep.
And it's just not enough to get like a working correct model. You also need it to be fast. And I would say that's been mostly true for like most of my career until especially in the last like 2-3 years, like some of these hardware neutral technologies actually started becoming really good. So things like Trident, like it's easy for like humans to look at it, but it's also easy for compilers to code generate it. That's why like, that's sort of the foundation behind Torch Compile. And then you see like projects like Tileline coming out, and it's sort of like in a similar spirit, like vendor neutral. And even then, fundamentally, even within NVIDIA's own libraries, like Qt 4, for example, they're starting to look more abstract in the sense that like how the code gen might happen could be vendor neutral, but the higher level APIs, I think is a good thing that they remain constant. Like, and I would say there's degrees to this. Like, for example, matrix multiplication is a very forward compatible algorithm. Specific like PTX instructions is not. And so like what is the right balance? And I think different like libraries will take different trade-offs. But like I definitely feel that on the higher level side of things, we'll just make it just easier for people to write code for more hardware vendors, more libraries, more compilers, etc.
Nice. I know, as part of GPU mode, you do have a leaderboard and an ability for, I think, even a Discord integration where we have, along with NVIDIA, you have an AMD, MI250 300s also hooked up. Can you tell us a little bit about your leaderboard?
Sure, yeah. So like the core idea behind the leaderboard is like, if you just look at the main questions people have on the server, it's usually, what should I work on? In which case we tell people like, here's a bunch of open source projects you can work on, but that's quite a high bar. And then the second question is like, where do I find free GPUs? And like, I think, for example, Google did an excellent job giving like a free T4 to everyone in the world. And I think for me, that was like highly inspirational in terms of like the right framing. And so similarly with the leaderboard, like sort of our insight was that it's quite expensive to give an individual GPU to every person. But if you just essentially have a single GPU and those run on a sort of job basis, it's actually very cheap for us to host this infrastructure. We've only spent about like $160 to take over like 2,000 like basically ranked submissions in the last month. And so similarly, it's the same infrastructure. You can join like a Discord channel. You type a message with here's like your like kernel file, like a .py, or like if it's a Trident kernel, or like a .cu, or like whatever other C++ library you might have. You submit it, and then you get results back within like 5 to 10 seconds. And people have really liked it. And for what it's worth, like while Discord for us, it's quite nice for distribution. We also like are now like, just as of today, we have a very nice like working CLI. So you can just be within VS Code or Cursor. And then you just essentially say popcorn CLI, submit. And that way it feels like you're on the same, it's your machine, but like you're not paying for it.
Nice. Yeah. That's great to hear. And I think accessibility to compute is going to be important to unlock this. Do you think I can use an AI to hack that leaderboard?
Yes, there's multiple aspects actually of hacking. So like one approach is like we've had AI effectively. If you give them the ability to look at the correctness code, there's like subtle issues that might happen. Like for example, let's say you have, I don't know, a vector sum kernel where you take all the elements of an individual vector and then you want to output a single scalar. If you sort of draw these numbers randomly, typically means 0, variance 1, you are likely to just output 0. So you don't need to actually write a kernel. You can just output 0 and you'll be number 1. AIs are very good at finding this, and smart humans that like have sort of a security-like mindset are also good at finding it. And for what it's worth, I do think like one day AI might be able to top these leaderboards, but it has anecdotally been quite rare. Like for what it's worth, a lot of these models struggle for correctness because they're not sure, is Trident code, is it PyTorch, is it CUDA? They sort of like confuse these things. And fundamentally, a lot of this is because we don't have enough tokens on the internet. So we really need more vendor neutral tokens on the internet. Otherwise, like LLMs will just sort of default to whatever is the popular library on GitHub.
Yeah, is it, so while you're in the process of generating these tokens, maybe we should package up the leaderboard as what all the AI evaluation benchmarks. You should make a GPU mode benchmark.
So that's exactly the intent, by the way. Like basically every 2 months, we're going to release the best kernels across all the leaderboards so people can study them, and they're fairly high quality. Anecdotally, just looking at GitHub at Trident kernels, a lot of them are the same.
Yep.
So there's not much diversity. It's like copy pastaing the tutorial over 6,000 times. Like that's not 6,000 times more helpful. And so fundamentally also, because it's a living thing and we're gonna monitor it and we can see different ways people might break it, that lets us have a more robust eval. And fundamentally, that's why my thinking recently also has been like, instead of just evaling over random inputs, what is the bar to have like an LLM generated kernel be mergeable in a project like PyTorch? Like that is like very unlikely to be reward hacked by virtue of time. Like it's an older library, it's well studied, people have sort of found all these like rough edges. And I think eval should evolve in a similar way for LLMs.
Right. Great. Do you have any predictions on like 2025 or predictions for AI, and then what would you like to see for 2025?
Right. So I would say there's sort of like a couple of hard research problems with kernel LLMs that I think are really worth thinking about. Like, which is typically kernel LLMs is framed as a translation problem from like PyTorch to like some optimized kernel problem. I would like to see more tasks that are like, what is the minimal edits I can make to a data set to speed it up, to a kernel to speed it up. Similarly, kernel discovery, as in like, how might you know that like flash attention is an op that's like worthwhile optimizing in an automated way? And the third one is like, what are like good abstractions that are like helpful for LLMs? Today, we're sort of assuming that if a programming language is short and readable, sort of like Trident, then it might be more favorable for LLMs. But like, I think I'd like to sort of have someone prove that out like more rigorously. And so like we can really know for sure. And that way we can make progress in designing like better GPU programming languages that are more accessible.
Nice. Good, Mark. Thank you so much for joining us.
Yeah, thank you for having me. Thank you. This is awesome. Thanks, man. Thank you.